These four equations are true anytime there's constant acceleration. If you're moving in a straight line with constant acceleration, these four equations will hold. So you basically just have to learn the four equations, just learn them as they are. And then to actually use them to solve a problem, you identify what you know. I suggest actually write it down. I'll show you in a minute. You select the right equation that's actually going to match the variables you've got. You substitute in and you solve. That's all there is to it. Now this is most easily shown through examples. So let me show you a couple of examples. First example. A sports car accelerates at 5 meters per second from rest for 4 seconds. If the car moves in a straight line throughout its motion, what will be the car's displacement during this time? And B, the speed after 3 seconds. So I recommend always write out what you know. So UVAST. To remind you, initial speed, U, V is final speed, really velocity, A is acceleration, S is displacement, T is time. So, for part A, acceleration is 5 meters per second. The time is 4 seconds. From rest, so it's going at 0 to begin with. You don't need the units because 0 is 0, but the units show that we match the rest. We're looking for its displacement. So notice, I don't know the final velocity and I don't care. In fact, for part B, I'm going to want the speed, but I don't want to write it here because it's actually only after 3 seconds. So I'll come back to that. So, let's have a go. U, A, S and T. Which of those four equations involves U, A, S and T? It's, S equals UT plus a half AT squared. Displacement's what I want. U is 0 times 4 plus a half times 5 times 4 squared. Just substitute in what you know. Solve for S. Is that 0? 2.5 times 16. And if you're not good at your maths at the moment, you go 2.5 times 16 and you get 40. Okay, the sports car has travelled 40 metres during that time. For part B then, I'm going to do the same thing. Write out UVAST, if only I can get it right. UVAST. Now, we're still going from rest. I want to know the speed after 3 seconds and the acceleration is still 5 meters per second. So, I have U, V, A and T. Which rule involves U, V, A and T? Well, it's V equals U plus AT. Put in what I know, substitute. V is what I'm looking for. U is 0, acceleration is 5, time is 3, 15 meters per second. The speed of the car after 3 seconds is 15 meters per second. Okay, let's try question 2. A cyclist accelerates at a rate of 3 meters per second along a straight road. If his initial speed was 12 meters per second, how long will it take him to travel 100 meters? So, like last time, write out UVAST. What do I know and what do I want? Acceleration is 3 meters per second. Initial speed is 12 meters per second. How long? I'm looking for time. Travel 100 metres. So now I want a rule that involves U, A, S and T. Well, that's the same as the first example. S is UT plus a half AT squared. Alright, put in what I know. S is 100, U is 12, T is what I want, I'll just leave it as T, don't need the time sign, plus a half times 3 T squared. Going to simplify that, 12T plus 1.5 T squared. That's a quadratic. Alright, let's try solving it. 0 is 1.5 T squared plus 12T minus 100. I've just rearranged so it goes the squared term first, then the T, then the constant. I don't really like 1.5. Am I going to be able to get anything else useful out of it? Or I could just get my calculator to have a go. Let's try that. So, menu, equations. I have a polynomial of degree 2. A is 1.5, B is 12, and C is negative 100. Solve. And there are two solutions. There's a lovely surd in my solution, but for physics I don't really care. Using GC, T is going to be 5.0921 seconds or negative 13.09 seconds. Well, can time be negative in this context? No. Time must be positive. Reject negative solution. So therefore it will take number of significant figures, it certainly doesn't need to be more than 2, 5.1 seconds to travel 100 metres.